So, in the spirit of the Maker Challenge, which Theo Kellison is running right now, I thought I'd do my own little project, even though I'm not actually part of the Maker Challenge. I thought, it'd be fun to do a little project and do something. So what you guys see in front of me is what's called a cloud chamber. Now, I'll go into more depth what a cloud chamber is and the science behind it. But basically, right now, to sum it up, it is a way of visualizing radioactivity. I have these two sponges that are glued to the side of the inside of the chamber, and those will act as a reservoir, which will hold an alcohol, which will be super cooled and basically cooled till it almost condenses. And that's when you can actually visualize the radioactivity. So let me do that. Let me get the dry ice in there to super cool it and get the alcohol set up. So how do cloud chambers actually work? So in the cloud chamber, what happens is that the alcohol in the cloud chamber is super cooled and turned into and because of that super cooling, it's turned into a super saturated vapor. And in that vapor, as ionization occurs from the ionizing radiation that comes off of something like a piece of yuxanite or a piece of uranite, what happens is as the ionizing radiation passes through the supersaturated alcohol vapor, the ionization basically acts like a center point for the supersaturated alcohol to basically condense. And so it condenses along this trail, and I managed to, even though I wouldn't say my experiment was 100% successful, I managed to capture on video a couple of these trails coming off of my yuxanite specimen that I put in there, which is kind of ironic because to speak about my yuxanite specimen, it is compared to my uranite specimen not as hot. And I'll put I'll probably have a bit of a video showing the different levels of radiation, probably right now. But comparatively, my uranite specimen is a lot hotter than my yuxanite specimen, but I only managed to, on video, capture the ionizing trails from the radiation coming off of the yuxamite specimen and not the uranite specimen, which is probably partially due to my chamber not being fully sealed, and also my reservoirs. I was dumb. These sponges, they act as like reservoirs and they hold the alcohol. They should actually be closer to the top because you basically want your reservoir to be a little hotter so that your stuff drips down, whereas at the bottom you want your alcohol to turn into a supersaturated vapor, so you don't want your reservoirs right at the bottom. And then on top of that, the metal plate that I was using wasn't perfectly flat, and so the bottom didn't seal properly, and so there was just slight lifts. So that meant some of the alcohol actually, before it could supersaturate, just kind of dripped out onto the edges of the metal plate that I was using. So I have to figure out a way to seal the bottom. And I mean, the container I used fogged up really easily. So I'm thinking I need to buy a different type of container the next time, something that won't fog up as easily, or put some anti-fogging stuff on it. I don't know. I'll try and figure that out. But anyways, back off of that tangent. Also, actually, one more tangent. My light source also, the light source I was going to use failed on me. And so I had to use another light source, which wasn't as good. What you want with this type of stuff is you want a kind of like a strip of basically LEDs is I think is the best setup. And you want that close to the bottom, right at the level of your specimen. And then you take your video from up top is actually probably the best way to look at it. And then you'll be able to probably track and see more of the trails, which is probably, I think my biggest issue was the bottom didn't seal and I didn't have the proper light source, so I couldn't really, there was probably stuff coming off this like a lot, but I just didn't have the proper light source for it, I think. But with the euxenite specimen, I got a couple trails. And those trails specifically, there's actually different types of trails depending on the radiation, because there's, of course, like alpha, beta, gamma radiation, and some other type of particles that are shot off of radioactive material. And the streaks that I managed to pick up, I believe, are specifically alpha particles, which leave these kind of very straight lines of condensation. But I definitely want to do this experiment again. I believe that I could be a lot more successful. I think I also need to get a better metal plate if I'm going to be self-critical, and I need to create a new chamber with something like, probably actually what I could do is, if I had the metal plate at the bottom, I just put some Vaseline on the rim of the container that I'm using. And then that way it'll just seal to the plate, and then I won't have any issues, and then I'll have the reservoir at the top, and I want the top to be clear, so that I think also the reason it's better to take videos from the top is because at the top you won't get the condensation, because I also ran into an issue where there was so much condensation like on the actual outside of the container at the bottom, because it was also getting cooled down, and so the moisture was in the air was condensing onto it. So that was an issue, and that was messing with the shots that I could get. But I believe if I fixed those issues, I would have a much better chance of getting a better picture and a better videos of ionizing radiation. So maybe later on in the summer, when I have some time after some of the work trips that I have to go on soon, I'll be able to build something like that. So I'll also probably actually just buy like a plug-in strip of LED lights and just kind of attach it to the bottom of the chamber so that the bottom is nicely illuminated. Because basically you want a really nice bright layer of illumination where you're going to be watching the radiation, because that illumination picks up the mist of the supersaturated alcohol vapor, and that will allow you to also pick up the basically the ionization trails a lot better. And hopefully in the future I'll have my second attempt and I'll be able to show you guys much better, and hopefully my uranite specimen will actually work out, because in theory it should have released more of the trails than my euxenite specimen, but it was only my euxenite specimen that I could get a good video. I could get video of these trails. Now I think it's just because of my poor light source that I had. I think that was my main issue. But hopefully in the future I'll be able to get a better setup and show you guys more. On the bright side, when you're done with the dry ice for the cloud chamber, you can dispose of it in a fun way. Look at all that smoke. Actually, incidentally, I think this is one of the ways that people get like a mist, is just by using a dry ice to create like a mist like this. So they just use dry ice to do it. We have gone into the end of the video. I know this video wasn't exactly 100% successful, but it did end up. I did end up capturing some trails on camera, so I'd say it wasn't a total wash. I also learned a lot from my mistakes. So I believe in the future I'll be able to use those mistakes to create a better cloud chamber system, so that I can do this experiment again and show you guys this radiation in a better way, and have better video of it, basically. I want to thank you guys for watching this video. I kind of made this video in kind of like an honor and inspiration of Theo Kelson's Maker Challenge. I wasn't part of it, and I'm not part of it, but I thought, you know what, I had this idea in my head for a while, and so finally his Maker Challenge kind of pushed me to try and create this cloud chamber and run this experiment. So even though it wasn't 100% successful, I'm still quite happy with myself. So thank you guys for watching. Please do like and subscribe, and I'll see you guys in the next video.